A star, 600,000 to 3,981,000 times more splendid than our Sun, displayed around 13 billion light-years quite a while back. Webb has now focused on this generally far-off star ever, and it's one of the most advanced telescopes ever to open new mysteries from the end of the star of astronomical first lights. It could be feasible for researchers to make sense of, interestingly, how the first stars in the universe truly came into being. It was an exciting discovery when the old Hubble Space Telescope originally found a star up until this point away that it blew researchers' minds. It's no big surprise that a star existed in space quite a while back. The marvel is that we can see it from Earth with our telescopes. The light from this star traveled 13 billion light-years through reality before it hit Hubble's fairly maturing perception reflect. The discovery of Ural, the most seasoned single star in the universe, was a late, brilliant idea for the telescope. Another scientific wonder is the fact that the star can be visible away from its world. This is possible because Endel was superimposed by a gravitational lens. Gravitational lenses are formed by solid amplifications when a huge mass lies before the far-off object, extending space-time in such a way that it behaves like an amplifying glass. Endel was, thus, optically expanded out of its system, enabling the identification of such distant stars. At these distances, recognizing individual stars is nearly impossible. What do such finds reveal to researchers? It's very straightforward. If we see a star that is average of the youthful universe, interestingly, we can finally understand what the stars of the first age truly looked like. Assuming we have insights about these stars, we can follow the historical backdrop of the universe's development and find answers that are urgently needed. As of recently, we had no assurance about what the first stars looked like. We have theories, but no confirmation. Endel should have been such confirmation. However, then the new Webb telescope arrived and turned everything upside down. What Webb really saw was a game-changer. Can you imagine how a solitary star literally turns into a superstar after its discovery? Endel stormed the media, and the reports came thick and fast. With the help of this oldest known star in the universe, the question of how the universe truly appeared should finally be addressed. Researchers were confident that, quite a while ago, the astronomical first light broke the once dark universe and was gradually illuminated by stars. Endel is an early English term meaning morning star or rising light. Some of you may also be familiar with the name from the book The Silmarillion by J.R.R. Tolkien. So, Endel was given a genuinely great name, and for a while, it seemed as though this star would truly go down in the history books. But then came the disappointment. Endel is old, extremely old. However, it's in no way, shape, or form the most ancient. In fact, stars from the first epoch of the universe should be blue supergiants, up to multiple times bigger than our Sun. These stars are said to have had only a short lifespan. Endel did not disappoint specialists when it came to its luminosity, being between 600,000 and 3,981,000 times more brilliant than our Sun. The star was truly brilliant and enormous. However, further investigation showed that it was the same in composition as today's giant stars. Endel, therefore, showed no proof of being a primordial star. Soon after its discovery, science was dealt the next blow. The new James Webb Space Telescope found even older stars and galaxies that are far older than Endel. The supposed Star of the Dawn was, therefore, downgraded from superstar to just one of many that existed at a possibly unremarkable time in the universe. Endel's light was emitted about 13 billion years ago, but the galaxies discovered by Webb were already emitting their light in space 13.6 billion years ago. This means that thousands of stars in these galaxies were and are around 600 million years older than Endel. By the way, the star remained the focus of science, even if Endel had to rapidly surrender its top position among the oldest stars in the universe. It's still an intriguing find. The illumination of a solitary star from this epoch reveals significant details to researchers about the structure and, accordingly, the formation of the star. Telescopes like Hubble and Webb can break down the light waves into individual frequencies. Analyses then allow precise predictions to be made about which gases the star was melding, how old it was, what spectral class it belonged to, and whether it was rare in any way. These investigations led to a new little sensation. The James Webb Telescope found evidence of a cooler, redder companion star in the star's environment. This could imply that we are dealing with a binary star system comprising a very large and hot star, along with a smaller one. This possible binary star system raises many new questions. New inquiries regarding the arrangement of the main stars since paired stars in the beginning of the universe have seldom been thought. The cool friend star could assist with deciding the synthetic arrangement and age of the framework more definitively. It is energizing that such frameworks could likewise provide insights into the associations between monstrous stars and their current environment. Such pairings might impact the dispersion of heavier components in the early universe more than recently suspected. Further observations with the Webb telescope ought to now explain whether this is, without a doubt, a twofold framework and what role it played in the development of the original stars. Star March. These are the most seasoned stars in the universe. Might we ever truly be certain that we are seeing the most seasoned stars in the universe? Since the disclosure of Endel and the resulting scientific bust, specialists all over the world have become more careful while picking names like Dawnstar or comparative assignments. In the meantime, gravitational focal points have provided further sightings of person stars in the universe, and these make Arendelle seem to be a spring chicken. SMSS J3336 to 670-8393 is nearly as old as the universe itself, at over 13.6 billion years of age. It was found in the corona of our own galaxy. This star is, therefore, prone to be one of the most ancient in the galaxy. This star contains scarcely any heavy elements, so it may be a direct relative of the original stars. The low metal content is considered typical for stars that were formed in an early stage of the universe and detonated as supernovae just a brief time later. Examination specialists were euphoric about this discovery, and they finally saw their speculations about the first light giant stars confirmed. Then, HD 140283 turned up and turned everything upside down once more. Estimations showed that this star is around 14.5 billion years of age, found around 190 light-years from Earth in our own galaxy. This star would be older than the actual universe. HD 140283 went down through the entire history of stargazing as the Methuselah star. Analysts still can't make sense of the existence of this star right up until now. The sheer incomprehensibility of the star even forces some researchers to claim that it could just be an estimation error. E1523-091 is also limited in our Milky Way and is around 13.2 billion years of age. An estimation mistake can be excluded here. This star was dated using a very precise method based on uranium and thorium estimations. E1523-091 is, therefore, perhaps one of the most ancient stars whose age has been exactly determined. It certainly existed 600 million years after the Big Bang, which would align with the old hypotheses. But then came BD plus 17 degree 3248, which, at around 13.8 billion years old, once again calls the Big Bang into question. This star also contains uranium, whose decay is an ideal tool for determining age. The strange age of this star could not be completely settled. If it truly existed 13.8 billion years ago, it cannot have formed simultaneously with the Big Bang. TAS J1180822025104378b is another candidate that challenges existing information. Its light was seen in the cosmic corona of our Milky Way, and it displayed there around 13.5 billion years ago. The very low-mass star shows signs of an original generation of stars. It was a giant light and probably lived only briefly. This could make it a direct relative of the first generation of stars. However, this isn't yet proven. Scientists are urgently searching for more evidence of very old stars of population 2. These are believed to have been the very first stars in the young universe, around 13.5 billion years ago. Although the Webb telescope can easily see back to this time, no proof of these star populations has emerged so far. The globular cluster M92 was dated to be around 13.8 billion years old. This could actually mean that the cluster was a kind of protogalaxy. Yet, with an age that precisely matches that of the universe, the globular cluster explodes the old timeline of cosmic evolution. These discoveries of individual stars, alongside Webb's finding of extremely old galaxies whose formation extends beyond the Big Bang, show that the universe must be older than we previously believed. The universe is 26.7 billion years old. Do you also can't help but wonder why researchers are so certain that the Big Bang happened 13.8 billion years ago when no one has ever really seen it? The dating of the beginning is basically based on estimations of the cosmic background radiation, which was long interpreted as a direct remnant of the Big Bang. Other values, such as the expansion rate of the universe and the supposed Hubble constant, seem to support this theory for quite a while. However, later discoveries and data raised the question of whether the universe could actually be older than previously suspected. Researchers found mistakes in the estimations of the speed at which galaxies are receding from one another. A long time ago, the difference known as the Hubble strain might have been an early indication that the age of the universe was being misjudged. You can imagine how scientists approached this as treating the expansion like a swollen balloon. If you let the air out of the balloon, all the visible matter would come together again at the starting point. This should be the Big Bang, 13.8 billion years ago. Further estimations and techniques confirm the universe is around 13.8 billion years old. However, now there is a whole series of real proof of stars and galaxies that existed when the universe was evidently starting. This real proof throws all old theories over the edge. The stars and galaxies are there. Scientists can no longer claim that there was nothing around then, or that the universe was just a hot soupy mix with no real matter. Despite this proof, a rethinking in science is slowly advancing. Imagine that you have believed in something your entire life and defended that belief. Then, an event or a person comes along and suddenly something else must be true. The brain, and also a bit of stubbornness and pride, can prevent new real proof from upsetting old thinking. This is what's happening in our astrophysics right now. While many modern scientists embrace the advancements, moderate researchers are stunned. They don't want to admit that the universe should be older and that old hypotheses are even faulty. We are at a fresh start. A Canadian scientist presented a new age estimate of the universe. He showed, mathematically and in accordance with the old physics, that the universe could also be 26.7 billion years old. Subscribe to the channel now and expect some new exciting videos.